Welcome to Chapter 11. And in Chapter 11, we're going to be dealing with measuring gases, and that means that we need to start with their units. So the first question that we're going to ask to kick this chapter off is, what is a barometer? And you may have seen one. If you never have, here's what a barometer looks like. And it's a cool looking device. It's got a couple of different readouts on this dial here. And since we probably have never really looked at one very closely, let's talk about what it does. And a barometer measures, isn't that interesting? Measures air pressure. And so I guess that means that we need to answer the question, what is air pressure? So let's take a look at what is going on with our atmosphere. In fact, so we're going to pretend that, we are just going to take a little walk. And this is what we see above us. Our atmosphere is actually made up of a bunch of different layers. What we need to consider is the fact that air has mass. And it's not as, say, massive as water. If we were to say that, water has a density of, say, 1 gram per cubic centimeter, air's density is quite a bit less. It's 0.0013 grams per cubic centimeter. However, if you stack that air pretty high, I mean, we're talking, look what this says, 500 kilometers. It's about 300 miles, 300 miles of air above your head. If you were standing here, that's a lot of weight. This is what we call air pressure. Air pressure is the weight of air, we'll call it. And you can probably guess that there's going to be more weight of air over your head if you're here at what we call sea level than it would be if you were up in the mountains, say in the Rockies. And you know that because if you go to the Rocky Mountains, it's a little harder to breathe because there's less air. The air is less dense. All right. So let's take a look at how we use a barometer to measure this weight of air. This is a pretty accurate representation of the first barometer, the first device used to measure air pressure, and it was devised by an Italian guy named Torricelli. He was a student of Galileo, so we're talking about the 16th, 17th century. And what he noticed was that this mass of air above this dish full of mercury, the mass of air pushing down on it from all this atmosphere, was able to support this column of mercury, which is a pretty dense metal, up to a height of 760 millimeters, this level. So this first barometer, and if this is at what we're going to call sea level, we just got, the higher up in the mountains you go, there's less air over your head, so there's less air pressure. So this is at sea level. And what Torricelli deduced was that at sea level, the air pressure was sufficient to support this column of mercury that was 760 millimeters high. So we're going to call this first unit the millimeter of mercury at sea level. Now, if we go back up to this first picture and zoom in, check it out. This barometer is actually measuring at the air pressure of wherever you're at in millimeters of mercury. And it's currently reading a little higher than that. And of course, those are weather phenomena, and we won't get into that. But here is our 760, which would be normal sea level air pressure. And here's a little sunny day icon that kind of tells you that, you know, everything's all right around there. And so we'll leave it at that. So we're going to call that our first unit of air pressure is the millimeter of mercury, and that it is at sea level. So what we're going to do is we're going to look at a few different units of air pressure, and I would like you to be conversant between them. I'll show you what we're talking about. All right, now before we go on, let's get a little bit clear on what we mean by supporting this column of mercury. Remember that the atmospheric pressure is pushing down on this amount of mercury in this vessel. Also, this mercury inside this tube is trying to fall into this vessel. It can only do that if this volume of mercury inside the dish is allowed to raise a little bit, but because air pressure is sufficient to prevent that from happening, this stays right where it's at, and that's what we want to be focusing on here. So here's what we mean by units of air pressure. If at sea level, standard air pressure can support a column of mercury that is 760 millimeters high, about 76 centimeters, here's what we mean by units of pressure. So here is our buddy, the millimeter of mercury. This is going to be a unit that we're going to say is equivalent to a torr. So obviously named after Torricelli. So 760 millimeters of mercury, we'll call that 760 torr. They are the same unit. We'll say that because this occurs under standard sea level air pressure conditions, that 760 millimeters of mercury is equivalent to 1 atmosphere. That's this guy right here. You can see it, 1 atmosphere is equivalent to 760 millimeters of mercury. The last unit that we're going to concern ourselves with is called the kilopascal. The Pascal is named after another scientist. And we'll say that 760 millimeters of mercury, which is standard sea level air pressure, which is also known as 1 atmosphere, we're going to call that 101.3 kilopascals. These are all equivalent, and if you are having a hard time keeping them straight, they're all right here in this section of this table, which I'll highlight here. That average atmospheric pressure at sea level is 760 millimeters of mercury, which is the equivalent of 760 torr, which is also 101.3 kilopascals. And of course, we're going to also make that synonymous with the atmosphere. Let me show you how we're going to use these units. I'd like you to be able to go back and forth between them. So let me give you an example of a question you could expect me to ask. So this one has got a couple different parts to it. It says, express a pressure of 570 millimeters of mercury in both atmospheres and in kilopascals. So we're going to set up 2 different conversions here. Let's do the first one in atmospheres, and we're going to ask how many atmospheres are the equivalent of 570 millimeters of mercury. So our conversion is going to look like this. We're going to have millimeters of mercury on the bottom, and we're going to go to atmospheres on the top. And we know from this table, and especially from this area here, that 1 atmosphere is equivalent to 760 millimeters of mercury. So let's put that in this conversion. We'll say that 1 atmosphere is equivalent to 760 millimeters of mercury. And hopefully you're not coming to class without a calculator. So we'll say that 570 millimeters of mercury divided by 760, this is 0.75 atmospheres. Let's do this second part, and we'll set it up the same way, except we're going to go to kilopascals. Can be a little trickier, but I'll show you how you do it. So how many kilopascals are the equivalent of 570 millimeters of mercury? Some people will convert millimeters of mercury to atmospheres and then atmospheres to kilopascals, but you don't really need to do that because these are all equivalents right here. And that means that 760 millimeters of mercury is equivalent to 101.3 kilopascals. So we'll just plug that right in there and do it all in one shot. And we'll say how many kilopascals are 570 millimeters of mercury. We're going to put millimeters of mercury on the bottom, and we'll put kilopascals on the top. That means that in 760 millimeters of mercury, there are 101.3 kilopascals. Bust out a calculator. Remember, we're multiplying across the top and dividing by the bottom. So 570 times 101.3 divided by 760. And we get 75.975 kilopascals. But if you're feeling frisky, you can just round to 76. Okay, that's all I'm asking you to do. So take it for a spin, and if you have any problems, give me a holler.